here's a video hint on question 3 where you need to design R1, R2, and R3 to give 0.7 volt drop from green yellow to ground and a 1.5 volt drop from red to ground. Now if the potential drops were equal, it would be easy. The resistors would be equal, and to minimize the power consumption we would set all resistors equal to 1 mega ohm, which is in general the largest practical resistor we can use in board design. But in this particular example, while the voltage drop across R3 is equal to the voltage drop across R2, making these resistors equal to each other, the same can't be said for the voltage drop across R1. So what you need to do is use Ohm's law to come up with relationships between R2 and R3. Right? And R2 will equal R3 because the voltage drops are the same. And then there'll be a proportion between R1 and R2 or R1 and R3. Rather than say, well, I'm going to solve for 1 milliamp of current or 1 microamp of current, we can just minimize the current by making a decision of maybe choosing R1 equal to 1 mega ohm and calculating R1 and R2 and R3. If you select R1 equal to 1 mega ohm, and when you calculate R2 and R3 it's greater than 1 mega ohm, well, you're violating your rule of thumb. So then what you would do is assume 1 mega ohm for R2 and R3 and calculate R1. And that hopefully at that point you have a value less than 1 mega ohm. There's really no way to know what's going to happen before you do it. I know the answer because I've solved this problem several times. And in experience, you might realize that, hey, 0.75 drop here with another 0.75 drop here means that this drop here is 2 minus 1.5. Hey, the drop across R1 is less than these. So that might give you the hint that R1 will have less resistance than R2. And eventually that will come to you. But in design, many times you will make an assumption, calculate it out, and it will violate some specification of your circuit, and then you just have to go back and redo it. That's totally natural, and you shouldn't be too frustrated by that.